Hello, React Rally. When you first learn React, you often hear this question asked a lot. Is React a library or a framework? I don't think it's a very useful question because it's just a little bit of both. My name is Sean, better known as Swix on the internets, and I propose that we stop asking this question and look at React as a language. When we take a linguistic approach to studying React, we can ask far more interesting questions, like how has the React language evolved? How might we evolve it in the future? How might we replicate the success of React language in other domains? I think a big contributor to the success of React the language, as well as every other language, has been the meta language around it. The core idea of this talk is that we can break a meta language down into 3Ds: dialects, distros, and DevTools. Before we talk about a meta language, we should try to define the language. Linguists break down a language into a vocabulary and a grammar. In other words, the set of all words and the set of rules for how to use those words. Most people know the vocabulary of React. You first encounter components, children, contexts, props, memo, render, hydrate, portals, refs, so on and so forth. But fewer people know about the care with which React's grammar was constructed. This dates back to the open sourcing of React, when Lee Byron redesigned the API to propose an explicit grammar for all of React's external APIs. All lifecycle methods took one of a few forms: should component action, component will action, and component did action. More recently, we added get var from source and get var from action. We can still see from this list that there are quite a number of concepts to hold in your head to master this grammar. And the lifecycle methods don't leave a lot of room for React to be intelligently re-rendering based on its own internal heuristics. The other downside is that there's no way to extend lifecycles except by creating a new component, which is what we all did with higher order components. So more recently, Sebastian and the rest of the React team made a genius maneuver by simplifying a lot of the grammar that we need to understand. So now we have the rules of hooks, and there are only two rules. They have to be at the top level, and they can only be React functions, and we mark React hooks with a use prefix. One benefit of this design is that custom hooks look very much like regular hooks, and that's very powerful for giving users the ability to extend the language indefinitely without increasing the surface area of React. For more information about this idea, check this talk by Guy Steele called Growing a Language. Over the past 7 years, React the language has also evolved tremendously. We used to create components with the create class API, and then we dropped that for ES6 classes. And today, 99% of components can be written as function components. We used to have React.autobind event handlers, and then we made it the default, and then we made it not default, and then we bound them in the constructor, and then we used class properties to bind them, and then we stopped needing to bind at all. We used to share code with mixins, and then we were told that mixins are considered harmful, and then we switched to higher order components, and then we were told to never write another higher order component, and then we switched to render props, and then we got hooks. React in 2020 looks tremendously different from React in 2013. And I think what's going on here is a very careful language design in order to tame the meta language required to use React. I was first introduced to this idea from Cheng Lu's React Conf talk in 2017, when he described any library, any framework, any language as consisting of two parts: a language, meaning the code we write, and then the meta language, meaning everything else that we do, including, coming to conferences like this one. Meta language is necessary, but too much meta language is also a design smell. As engineers, we all want to do work instead of busy work, but sometimes we get too stuck in the busy work to try a better way. While all Turing-complete languages are equivalent, the purpose of language design therefore must be to attempt to minimize the complexity of meta-language and to maximize the productivity of language. I like to draw the analogy to keyboards. We're all familiar with the QWERTY keyboards, but we've also seen stenographers transcribe what we say at amazing speed. I did some research, and it turns out that stenographers have about 7% higher accuracy, which is unsurprising because they trained to do that. What's really amazing is that they're about 5 times faster than most typists, and they do it with a fifth of the number of keys. Learning to type in steno is its own language that happens to compile to our language, but this comes first and foremost from careful language design. React is a hugely successful language for UI programming. What is the steno keyboard of React? What if, just like the steno keyboard, we can also focus on a few key levers to write and grow a meta language? I've been trying to discover what they are, and I think it comes down to 3 things: designing domain-specific dialects, curating and maintaining good distributions of them, and creating great developer tooling. So first, let's talk about dialects. Why do we even want dialects? Because our original language may become very inefficient based on our needs or preferences. If we consider mathematics, we might take a long time to parse this statement on the left, but if we invent special syntax, then it becomes much easier to see patterns and apply domain-specific rules. If we consider music, we might take forever to describe precisely what we want in English, but if we invent a special format for it, we might be able to encode and decode it much more efficiently. This is basically how JSX spurred initial adoption of React inside Facebook. When React was open sourced, the way to create React elements was using react.dom.div and react.dom.button. In 2013, JSX was introduced as an optional preprocessor, taking only one slide in Pete Hunt's original React presentation. Today, it's still optional, but it is the overwhelming default way to write React, transpiling to the new API of react.createElement. But there are many other ways to write React. The first thing we want to do is add types. Out of Flow, ClojureScript Ohm, and Reason React, TypeScript kind of won with great focus on tooling and community. Today, the vast majority of the React ecosystem not only ships TypeScript types, but have internals written in TypeScript too. If you want to learn how to add TypeScript to your React repertoire, check out the React and TypeScript cheat sheet that I maintain together with other collaborators. The other first-party dialect of React is React Native. Yes, this is still React, but in no other format do we write view and text, and we don't do stylesheet.create in anywhere else except for React Native. So this looks like React. It uses React's concepts, but it has a different dialect to it. It's got different idioms and different nuances. The next thing to tweak is the ergonomics of JSX. The HTML-like syntax of JSX is familiar, but it can be verbose. Pug and CoffeeScript React are two notable alternatives, but probably the most successful so far has been MDX. MDX does to JSX what Markdown does for HTML. MDX is really powerful for writing interactive, customizable docs with React components. Today, every single React documentation tool speaks MDX, from Facebook's Docusaurus to DocZ to the other DocZ, naming is hard, and even Storybook. Another secret dialect of React is the globals dialect, which nobody likes to talk about. We say we like making the implicit explicit, but one dirty secret of React is that far more of us use magic globals than we admit. Over 100,000 of us use Babel plugin React Require, which in effect makes React a global library. It's built into Next.js, so everyone who uses Next.js uses this dialect of React. By the way, in the near future, you won't need to think about this as it was recently merged into the main JSX transform. So JSX itself is evolving to accommodate the need for this magic global. Every Jest test uses magic globals. Every time someone configures absolute imports, they're trading some explicitness for magic. Facebook itself uses haste, where every file name is globally unique. So even the creators of React don't use React like they tell you to. It begs the question, how else can we wisely insert magic into React? How about styling? We have a dizzying array of inline styles, from BEM CSS to utility CSS, CSS modules, and CSS and JS libraries. What's missing from this discussion is how often we lean on non-standardized methods to do styling in React. Many beginners don't even realize you can't import style.css or use CSS modules without a bundler plugin. You can't write style.jsx or use the CSS prop without Babel. And let's not even discuss how we do transitions and animations in React, or how to publish any of this as reusable components on NPM. All of these little patterns and setups are tacit knowledge that form little silos of React dialects throughout our community and make it that much more intimidating to beginners. If it sounds like I'm making fun of all this experimentation, I'm not. I think we're just not being ambitious enough. Because we don't see React as a language, we try to make local tweaks around an obviously incomplete language, rather than to try to properly grow it for a clearly developing community need. No wonder everyone feels fatigued. The success of MDX, launched in 2018, shows the way. Nobody wants to open and close P and A tags all day to write documentation, so we made MDX as a dialect of React for documentation. So what other domains can we apply this idea to? In 2019, Storybook created the component story format, which is a dialect of React for displaying component variations. This year, in 2020, Redwood.js debuted cells, which are a dialect of React for data fetching components. They combine GraphQL queries with loading, empty, failure, and success components. The The genius of both these dialects is that they are just JavaScript, easily consumable by other tools. This means you can directly use CSF files in jest tests, or statically extract GraphQL queries from cells, and benefit from all JS tooling from syntax highlighting to TypeScript. I think, aside from MDX, future React dialects should bet on JavaScript as far as possible. I think there will be more React dialects. As React's user base grows, and as we understand our problem domains better, we should write domain-specific React. One of the most obvious ideas that we can copy from other frameworks is this idea of single file components. We have them in Vue, Svelte, and Angular, but for React, the trade-off is a little different because React bets heavily on JavaScript instead of any HTML templating language. We'll probably want to support existing tooling and local mutability, and have some features of a sufficiently smart compiler that make React a lot less verbose to optimize. If you're interested in discussing these ideas further, I've put up my proposal for how React's single file components could be written that takes into account all of these criteria. Just remember that this is superficial sugar that is not for everyone, but it might someday be as commonplace as JSX, which was also originally controversial. 2 years ago, Dan Abramov noted that a good recipe for success is to take something that's easy to debug and make it less annoying to write. He was actually talking about immer making immutable operations easier, but I think that's actually something we can apply to React. In a sense, that's the entire goal of React dialects. Take something that's easy to debug, React, and make it less annoying to write for a particular domain space. The second part of this equation is React distros. The React language and its dialects are nothing without the right environment to run in. Although we rarely use React as just a browser script. At minimum, we expect to be able to bundle dependencies for production, code split for size, and have a development server to do live and hot reloading. React's first really popular distro was React Boilerplate in 2015, and then we eventually moved towards zero config toolkits with Create React App in 2017. And since then, the number of React distributions has really grown. I liken this to the Carlota Perez S-curve model of technology innovation and adoption. First, we go through a slow phase of creative destruction, and then when everyone has settled on a standard or a set of technologies, then everyone else jumps aboard. This has been used to explain all types of technology adoption, from the telephone to the tablet. I think this applies to JavaScript frameworks. We used to have this tired meme of there being a new front-end framework every month, but now the clear leaders are established, and React 16 is going to be celebrating its 3rd birthday this year. You see the innovation being on top of React instead of competing directly with React. This is the typical behavior you see in the deployment age, and is a direct result of React's decision to have a small API surface area. React's distros perform 2 jobs. They curate an opinionated set of tools for a given target audience, and then they bundle all these tools into one and share the maintenance burden. This makes React sites and apps much easier to write, from Create React App for single-page apps to Next.js for hybrid static and serverless sites. Probably the hardest distro to get right is the full-stack React distro. Meteor.js has been doing this for a very long time, but the new attempts this year have been Redwood.js and Blitz.js. I think there's more innovation to come. These are all wonderful projects with great new ideas, but we need even more innovation that matches the growing diversity of needs. For large apps, we need to do better with code splitting to make it easier and more intelligent. After all, the fastest code is the code that you never have to download and never have to run. The basic ideas of progressive hydration and selective hydration and predictive prefetching have been sketched out, but we're still waiting for the patterns and primitives to make them truly widespread. This will likely involve a much tighter integration between React and its distros, with seamless movement between server and client. This is something that Blitz, Next.js, and Redwood.js are all exploring, and it will likely mean that React the language evolves to more formally include the full stack. As Frank Yen showed with Facebook's Stylex, this also means that React distros will have to account for styling solutions that scale. For small apps, we need to do better adopting Preact by default. The difference between 120 kilobytes for React and 10 kilobytes for Preact is huge for the majority of sites. We need to be mindful that the mass majority adopting React don't know the difference and never use React for features that Preact doesn't have. This will help keep React the language in the game compared to Vue and Svelte for small apps. Speaking of which, the React single file component idea probably also needs a distro, so I went ahead and made an MVP. So let's take a look. Okay, so I have a demo React app running here, Everything is normal about this except for one difference, which is I'm importing this sfc component from sfc.react. So this is a new file type that I've established. And if I go into sfc.react, I can see some JavaScript code, but it's not syntax highlighted properly. Fortunately, I can use existing tooling to do that. So I'm going to, inside of VS Code, I'm going to open my settings and set up the file association for that. So here it's going to be star.react, and I'm going to set up that association for JavaScript. And that should do it. So now you can see there's some syntax highlighting here. And if I change this, for example, I'll say hello world, it's going to actually update over here as well. If I want to, with this new file format, I can actually take advantage of Prettier and do format document, and it works just the same. The first and most obvious benefit of a single file component is that I can co-locate styles with this. So let's try it. I'm going to use the convention that I picked. So it's export const style, and then it exports whatever I want. And inside of here, I can put whatever I want. So for example, if I say div and I want to change the color to red, this should update accordingly, and that should change the color to red. Maybe the font size is a little small, so font size 2 rems, and that should bump it up a little bit. So that's interesting. Let's add a little bit of state to this. Typically in a React project, I would have to do something like import useState from React. Notice here that I don't import anything. Because I'm in a .react file, it's just understood that everything here assumes that there's some level of React API available. So the custom syntax that I've chosen is that anything with a $sign gets treated as a particular form of state. So I'll say, for example, something like counter equals to 0. And I can use this inside of my app. So I can go inside of my JSX and put in the counter variable, and it should update accordingly here. Let's change this to a button, since obviously that's the little more semantic thing that I want to do. So button. And here typically I would have to set up an on-click handler with a set state, but since I'm using this mutable syntax, I can actually just mutate that variable and it compiles accordingly. So I'm going to have the arrow function, and it'll say counter, $counter, ++. And that sets up the button accordingly. I don't like the way this button looks, so instead of leaving the file, I'm just going to go up to where the style's already defined and change it from within the same file. And if I save, that should look like a much nicer button that I have over here. Now these styles are static, and if I wanted to make them a little bit more dynamic and use some CSS and JS, I might have to swap out tooling, install a bunch of libraries, and that's a whole thing. But if I build them right into the compiler, then I don't have to make that choice. The compiler can just understand what I'm trying to do. So for example, here, this is a JavaScript template literal. So I can escape this color and change that into something where I can take a modulo of the counter variable that I'm also using inside of my button and toggle between either papaya whip, which is obviously the best CSS color, or green, which is the one I started with. So let me save that. And now every time I increment this button, it's going to change the color. So this is pretty handy. Obviously, this is just a trivial attribute that I'm changing, but I can apply this to the entire selector, or even things like media queries, which are not possible in some styling systems. The design goal for all of this is that adding functionality should involve a very minimal upgrade path, instead of having to change tooling or to restructure code dramatically just to achieve common tasks. So this is good for a simple button example, but there are other pain points in React that we can actually try to make easier. So for example, if I delete the styles that we've established and I replace the button with a form, that's a more common pain point in React. We might normally set up individual pieces of state and then wire it up with the value and the on-change handlers, or we might reach for a library like Formic or React Hook Form. And this all really boils down to React not having two-way binding, which is a good overall principle to have. But if you scope it to a single file component, then it might actually be a pretty useful thing to have. So for example, here I just have a static form where I have an input for height and input for width. And this image element just pings the Unsplash API with those height and weight requirements for a random image. So let's try to see if we can make this into an interactive app. Okay, so let's set up the two state variables that we're going to need. So I'm going to change this counter to height, and I'm going to change that to width. And now I have two state variables. So I can put that inside of the value, just like I would a regular React state variable. And this would be width. If I save that, That should show up here as well. I should set these defaults to 300. But if I try to change it over here, nothing happens. And that's because these inputs are now controlled components. So in a normal React paradigm, I'll have to set up an onChange handler for each of the inputs that I have to set up. This can get kind of tedious. That's why we bring in form management libraries. But we can take advantage of syntax to automate this for us, since most of the time we just need to handle them on submit. So here I've added my special binding syntax, and that says any attribute with a $ preceding it is bound to whatever is on the right-hand side. So if I save that, I can now increment and decrement these inputs and control components. That's great. And of course, the final step is to replace the API values with the interpolated JavaScript values. So that's height and that's width. And if I save that, now I can request for arbitrary images. Yep, that's nice. I can also go for 200, I think. 200. And that should be nice as well. Great. Of course, because we're taking a compiler approach to handle all of this stuff, then we have to replicate all of this logic for all the edge cases. For example, what if I change this to a single size variable which is an object that has height and width of 300? I would expect this to work just by adding size.height over here, size.height, and size.width. And here it actually does because, well, I fixed the bug, but we would have to figure out all these edge cases and have a good test suite for them. But it can be done because that's how other compiler frameworks handle their transformations. But notice that because I'm sticking close to JavaScript, I actually get the benefit of a lot of JavaScript tooling. For example, VS Code has a language server that's analyzing this JavaScript file. So if I hover over size over here, I get the inferred type of size, even though I'm not actually using TypeScript anywhere here. And that also means I get autocomplete when I type inside of my editor. This is the kind of thing you get for free when you stay close to JavaScript. However, when I introduce special syntax, for example, the $value binding that I have over here, I don't have the benefit of tooling to help me. So I start to need to write my own tooling. And that brings us to the final argument of our talk, which is DevTools. So, okay, we have a dialect, and then we have a distro to support that dialect. So now the question facing us is, how can we make development faster, easier, and less error-prone? Fortunately, I think in JavaScript, there's been a growing culture of acceptance of DevTools. Anytime we write tests, that becomes a custom-made dev tool that tells us when any part of our app breaks. The React ecosystem has definitely embraced TypeScript in a big way, and that is another dev tool that helps us reduce runtime errors. And even when you run Prettier on your files, which did not exist 3 years ago, that's a dev tool that actually helps you format and check that your file is valid syntax. All of this developer tooling is not required, but it has the same underlying goal, which is to shift left. And this is an idea brought in from product development that uses empirical research to show that the earlier we can catch a bug, the cheaper it is to resolve it. So we can take this similar concept and apply it to our kind of software engineering, where we can break up the opportunities for bugs to surface from the runtime to build time, to commit time, to save time, and to read time. And the shorter that we can make that feedback loop, the faster we can fix our software, and the cheaper it will be to fix our own bugs. In React, we've also seen quite a lot of tooling specifically to help us shift left in terms of our software development. And I particularly want to highlight the work of the React team in both React Native Flipper and React DevTools. These are incredible tools that help us discover bugs before we commit and build and run them. In 2017, Tom Dale from the Ember team made a prediction that compilers are the new frameworks, that all frameworks would have some form of compilation step. And indeed, the React single file component idea that you just saw is the same idea that's built into Svelte, just brought over to React. But I think Tom did not go far enough. So my prediction for 2020 is that language servers are the new frameworks because they help you shift left all the way to read time where the feedback is instant. Here you can see my totally unscientific chart of where each framework is going, and you can see that all of them are shifting left in some form. I don't think that any of this is a nice to have. I think that if we want web development and JavaScript frameworks to remain accessible to a growing number of people, then we have to take the same approach that we take for computer-aided design and start to embrace computer-aided development, possibly using GPT-3 or visual builders like Webflow and FramerX. But that's the long and short of what I think the future of React holds. More dialects, more distros, and more dev tools. And the main reason I'm predicting that there will be many dialects is just the sheer and growing number of people using React. Current estimates are that there are at least 3 million React developers, probably more, and they're probably not going to have homogeneous needs and preferences. They're probably going to be a little bit more diverse and hopefully increasingly diverse over time. And we're going to discover commonalities among them so we can group them together into tribes that have different needs. So of course, they're going to want different dialects that suit their needs better than what React itself can afford. I think the best way to understand this is to think about how human language evolves. What makes the difference between a dialect and a language? Why is it that Danish and Norwegian are so similar, but they're considered different languages? And Guangdonghua and Minanhua are so different in tone, at least to me, but they're considered dialects of the same language. And the core insight that all linguists have settled on is pretty funny. It's this insight by Max Weinreich, who's a linguist, and he says language is a dialect that just happens to have its own army and navy. And that's what linguists jokingly call a language. But I think the joke is almost correct. What they're really talking about is the need for a powerful meta-language in order to be considered a language. Therefore, for us, the takeaway is more that we have to grow these three specific parts of a meta-language, the dialects, the distros, and the dev tools, to create a popular and productive language. So if we think about the specific job to be done, we want our dialects to be custom designed for the specific needs of a group of people. We want there to be a good distribution with curation and maintenance. And we want our developer tools to shift left the process of software development. That's how we can analyze the success of React going from library to language. It started out as a dialect with JSX, then we got an official distro with Create React App, then we got dev tools, and it's no surprise that all three of these are created by the React core team. What's really cool is you can see the same pattern play out in other communities, like with GraphQL, which started out as a pattern inside of Facebook's Ents, and then got extracted into a schema, which then got an official JavaScript implementation, and of course, the killer app is graphical. How about CSS? Tailwind started out with this weird utility dialect of CSS. Then it got supercharged with the official distribution of Tailwind UI, and I'm not in the least bit surprised that the first employee of Tailwind Labs is the guy who worked on IntelliSense for Tailwind inside of VS Code. This trifecta is not just for front-end. Where I work at AWS, the dialect we use is AWS CloudFormation for declaratively setting up your backend. The distribution for front-end engineers is AWS Amplify, and the dev tooling that people use is an assortment of CLI tooling. I think what this shows is a deeper pattern for technology adoption that is often described by the Rogers curve. This was popularized by the book Crossing the Chasm, which talked about the big jump between what is good enough for innovators and early adopters and what the majority and late adopters expect. This corresponds nicely to a focus on language first and then meta-language in later stages. And if I had to match each concept to a stage, it would probably look something like this, although they are important throughout the lifespan of a technology. So that's the crux of my argument today, that you need to grow a meta-language to strengthen the language. And the key pieces to work on are identifying the dialects, distros, and dev tools that get you there. What I love about these three things is that you don't need anyone's permission to work on them. Just look at the technologies you use and build what's missing. Who knows, in the process, you might end up creating the next great language. And that's my talk on growing a meta-language. If you'd like to go deeper and follow along on my understanding of React, I recommend these 4 talks. And you can find those links, these slides, and even more details on my site at swix.io/talks. Thank you for having me, and enjoy the rest of React Rally.